this is going on page 28, and we're done. We're going to talk about piecewise functions today. If you were in a pre-AP Algebra 2 class last year, you did piecewise functions. If you were not, you most likely did not. So maybe new to you, but maybe a review for some of you. So what are piecewise functions? Exactly. So it's just like it sounds. It's a graph with different pieces, right? And they don't overlap because they are functions. This is important, right? Functions. So these are functions defined by two or more subfunctions, each with their own domain. Two or more subfunctions, each with their own domain. So instead of just having a cubic or just having a quadratic, I might have part of a cubic, part of a quadratic, part of a linear, part of whatever, okay? And we define which pieces we have by the domain. So if you look at this number 1 here, f of x, so we have this one function, and it's defined by these three subfunctions. I have an absolute value function, but that is only defined for when x is less than -3. I have a quadratic when x is between -3 and 7, and I have a square root when x is greater than 7, okay? So when we go to actually evaluate, we're going to evaluate a couple of them before we graph. When you go to evaluate, you have to decide which piece are you evaluating it in, because you don't take -5 and substitute it into all three of them. That doesn't make any sense, okay? X is -5, right here. So where does -5 fall in these, in the first, second, or third one? The first one, because it was when x would be less than -3. So I substitute -5 in here, and I get 2 times the absolute value of -5 minus 5. So -5 minus 5 is -10. Absolute value of -10 is 10 times 2. F of -5 equals 20. Make sure you are labeling your answers, that you don't just put 20 and box it. Then I want to find f of 2. Does 2 fall into the first, second, or third? The second, because 2 would be between -3 and 7. So this is going to be -2 squared plus 4 times 2. So it's going to give me -4 plus 8. So f of 2, oh, that's an x. F of 2 is equal to 4. Okay. Then we evaluate 7. Does that fall into the first, second, or third? Third, because it says greater than or equal to, so it falls in the third one. So this is equal to the square root of 2 times 7 plus 6. So that's the square root of 20. And when I simplify the square root of 20, what do I get? 2 square root of 5. All right, what questions do you have? Easy enough? You understand how to figure out which one to substitute it into? All right, let's do the next one, because there's a couple things that come up here. All right, g of -3. Does -3 fall into this first, second, or third? Second, right? Because -3 is between -4 and -2. So g of -3 is equal to what? 8. There's not even any work there. It's just 8. Doesn't matter what x is. Then g of -8, does that fall under the first, second, or third? First. So this is equal to 1/2 times -8 cubed plus 7. So I have to cube -8, which I can do 8 times 8 is 64, multiplied by 8, whatever. But this is one of those here where I want to talk about let's think smarter, not harder. Now, I wouldn't expect necessarily for you to write this out in your work. You might want to in your notes, so it's up to you. But this is what's happening, right, in a sense. And so I could multiply all three of these together, then take half of it. There's nothing wrong with that, except that makes my number really big. What's -8 times -8? 64. What's half of -8? -4. Isn't it going to be easier to multiply 4 times 64 than it is 8 times 8 times 8 and then take half of it? So if you think before you just jump in and start doing math, you can simplify your life a little bit. Because now to multiply this by 4, I just double it and get 128, and then I double it again. So when I double 120, I get 240, double 8, and I get 16. So that's going to give me, oops, I got caught. It's going to give me a negative what? 256. It's the first time I got caught like that. All right, equals negative 256 plus 7. So that means that g of negative 8 is equal to negative 249. Good. All right, then we have a decimal. Oh no. 3.1, where does that fall? Good, the last one, the greater than negative 2. So that means I get the absolute value of 3.1 minus 4. It's the absolute value of negative 0.9. So g of 3.1 equals 9/10. Any questions at this point? All good? All right. So let's talk about graphing. Shouldn't be new to everybody, but it may be new to some of you. But if you can graph the other stuff, you can graph this. So it's really not that big of a deal. Okay, so I've got these two pieces that I'm going to graph. I've got this first one, which is the parent function is absolute value. And then the second one, the parent function is linear. Right? So got to know what those are to be able to start. Now, since I'm only doing pieces of these, I'm going to have starting and stopping points. So it's good to go ahead and get those graphed first. See how this is true when x is less than 0. This is true when x is greater than or equal to. So that means that for this first function, 0 isn't actually something I get to use. However, what I do have to put it on here, and when I put it on here, what's it going to look like? Open circle. So I do need to actually figure out the value. So I substitute 0 in here. Get 0 plus 3 is 3, minus 1 is 2. So at 0, 2, I have an open circle. And that's the right-hand side of my absolute value. That's where it stops. Okay. So then I've got to get the rest of that function graphed on here. So now I'm going to do this just like we did on the other stuff with the parent functions. I'll start with 0, 0 as an anchor point. Because I know that that's, for my parent function, that's my absolute minimum. So up here then, reflections to the left, 1, 2, 3, and then the 1 down 1. Okay, so since I didn't reflect, that is still my absolute minimum, right? It's the bottom of V. That means that over here, I can go ahead and draw that part in, and I have the right-hand side of my absolute value, okay? So now I need to get the left-hand side. I got a couple of options. I can use the anchor point negative 1, 1 and figure it out, or since I do know this is still the absolute minimum, can I use symmetry here? Yes, I can. So I can go left 3 and up 3, and I've got this point right here. And then I can graph that. And there you go. So that's the only part of that absolute value function that actually exists for this function. Now we do the linear. So now I substitute in the 0 into that. 2 times 0 is 0, minus 5 is negative 5. So I go to 0, negative 5, 1, 2, 3, 4, 5, and I put a closed circle because it's included. Do I have to do anything fancy or weird to get the rest of the line? No. What's the slope? 2. So I go up 2 and over 1. Then I'm done. Okay. What questions do you have? Anything? You don't know yet? Okay. But right now you don't have, that's okay. And sometimes you don't even know what to ask yet. That's okay, as long as you don't have anything pressing right now. All right, so, but do you understand where everything came from? Yes? No? Oh, yes, kind of? Why just kind of, Jacob? You don't know yet? Okay, this one just came from me doing the parent function transformations like we did yesterday. And then because I knew this was the absolute minimum, I just used symmetry to get that point. Okay, and then I got this one by substituting 0 into the second part. And then I just used slope. Okay. All right, so now my domain. Are all of the x's in the domain accounted for? Like, are all x's ever accounted for? Yes. So I'm going from negative infinity to infinity. Are all the y's from negative infinity to infinity accounted for? No. What's the smallest y value I have? Negative 5. Good. And then it goes all the way to infinity, or no? Yes. Okay. Do I include the negative 5? Yes. Are there any discontinuities? Yes. What kind? Jump. There's a jump discontinuity, and it's at x equals 0. Yeah. Point still looks like an open circle, but it would be inside of a line or inside of the curve. If you jump, like this has to be open or it wouldn't be a function because it'd be evaluated at both of those. Okay. We're all good? All right, flip it over. Let's look at another kind of simple one. So for this first piece, this is another linear. All right, so there's one linear. This is quadratic. Okay. And then I'm going to take that negative 3, substitute it into the first one. So I get negative 4 minus a negative 3. That becomes what? Plus 3, so it's a negative 1. So negative 3, negative 1. Is this opened or closed? Closed because we include it. Okay, so that's 1 point on my line. So since it's a line, I can just use the slope to figure out the rest. What's the slope? Negative 1. So that could mean that I go to the right 1 and down 1, but is that point actually in that domain? No. So instead I need to go up 1 and to the left 1, get my other point. Then you can use your straight edge to get your line in there. So that's the part of the linear that we're using. So then I'm going to graph the quadratic. So the first thing I do is take that negative 3 and substitute it in. So negative 1/2 times negative 3 squared. So that's going to be a positive 9 times a negative 1/2, negative 9/2. So when x is negative 3, y is negative 9/2 or negative 4.5 when I go put it on the graph. 1, 2, 3, 4.5, and it is open. So now that I have the left-hand side of that parabola, I go and do the rest of it just like you were doing on the rest of the graphing. I'm going to start with the vertex because currently it's my absolute minimum, and that can kind of help me understand what's going on with this graph. So from here, at 0, 0, I'm going to reflect it. It's still at 0, 0. I have that 1/2 compression, still at 0, 0. So 0, 0 is still 0, 0. Those 2 points are not enough to graph my parabola. So another anchor point I have for the parabola is negative 1, 1. So I start here. I reflect it in what? The x-axis. And that 1/2 does what? Compress it. Which way? Vertically compress it, right? So I'm right there. Everybody okay with where that point came from? Now that I have this, since I know that this is the vertex and I have these two, I can use symmetry to get the other two. I got that one there, and I got that one there. Then you just do your best to draw in your curve like so. Okay, what questions do you have? Anything? All right. Domain, are all the x's or all real numbers taken care of for the domain? Yes. From negative infinity to infinity, it's continuous. So negative infinity to infinity. Is it continuous for the range, negative infinity to infinity? Yes, it is. Negative infinity, all the y values that exist are taken care of. And we have what kind of discontinuity? Jump. No, not necessarily. We've got the jump at x equals negative 3. All right, let's check out number 5. What's this first one called? Reciprocal. So here's my parent function. And the second one is linear again. Been really nice with all these linears, right? So I'm going to start by substituting in that 1 first. Substitute that in. That gives me 4 over 4, which is 1. So 1, 1 is my first point, and it is, I'm sorry, yeah, it is 1, 1, right? Yeah, 1, 1. Sorry, the brain brain fart there. And that's my first point. Then, since I am graphing a reciprocal, the next thing I want in here are my asymptotes. So I know that I'm supposed to have an asymptote in the parent function on the y-axis. Was this graph shifted left or right any? Left 3, right? So it ends up here. I also know I have an asymptote on the x-axis. Was this graph shifted up or down any? No, so it's still on the x-axis. Okay? Now, were there for the reciprocal any reflections? No. So that means that this right here would have come from an anchor point that would have been in this part of the graph. So I need one down here. So I'll start with my anchor point that's -1, -1, right? What does that 4 do there? It's a vertical stretch. So my y value now becomes -4. And then that 3 moves me to the left 3. There's another point. So now I have 1 point in each section of the graph, and I can get another point in those sections by using that symmetry, right? By using that y = x symmetry where the asymptotes intersect. I start there. To get to this point, oh goodness, I go to the right 4 and up 1. So instead I go up 4 and to the right 1. Gives me that point right there. Start here. To get to the one that's there, I'd have to go down 4 and the left 1. So I go left 4 and down 1. That's where I get those reflection points from. Then I can draw in this part of the graph. But then when I draw in the other part, I got to be careful because I don't draw the whole thing. This is only good until x is equal to 1. So when I draw this in, I have to stop right there. And then I need to actually kind of erase that because even my asymptote only goes to that point. Okay. Everybody with me so far? Because I only get the reciprocal function when x is less than or equal to 1, and that's what I have graphed so far. Then I move on to the next one. I substitute that 1 in. 2 times 1 is 2, -7, -5. So we've got a 1, and then 2, 3, 4, 5, and it's an open circle. Then it's linear, so what's the slope? 2, so I can go up 2 and over 1, get my other point, and there's this piece. All right, everybody good so far with that graph? Is the whole domain from -infinity to infinity covered? No, because I have an asymptote. So I go from -infinity to -3, and then -3 to what? To infinity, because all the x's have values there. For the range, are all the y's taken care of, all the way up? Yes. Now the asymptote affects the y equals 0, but when this line comes through, then I do have a y equals 0 there. So we are good from -infinity to infinity. Are there any discontinuities? Yes. What's the asymptote give you? Infinite. So this is infinite at x equals -3. And then we have jump when x equals 1. And to answer that question again, there's not always a jump. There might be on all these that we happen to do, but it's possible that, like, if this line was shifted up, bless you, it could actually be connected to this curve. Like, we could have a curve and then it turns into a line. Like, that's a possibility too. All right, we're going to do 7. We're skipping 6. So for 7, this parent function is a linear. Then I have a cubic. And then I have a square root. Okay? Wait, what? I'm on 7. I skipped 6. No, I didn't. Were you sleeping? No, we skipped 6. We're going to 7. I'm on 7. Everybody look at 7. Skipping 6. All right, so that -1. When x is less than -1, y is equal to 7. So at -1, I go to 7. Is this opened or closed? Opened. And then what does the rest look like to the left? Straight line. Okay, all lines are straight. Give me some different words. Horizontal line. Good. All right, so horizontal line. Here we go. All right. Then I have 3 pieces here. So that middle piece has 2 ends, so I got to do both of them. Take the -1, substitute it in. -1 cubed is -1, -1 is -2. So -1, -2, and that's a closed circle. Then I substitute in 2. 2 cubed is 8, -1 is 7. So I go to the right 2 and up 7, and it's closed. And clearly that's not enough points to get my curve in there, because it's supposed to be cubic, and that doesn't tell me much. So I've got the 2 endpoints. Then I can start doing my anchor points. I'm going to start with 0, 0. What does that negative do? The negative reflects it in the x-axis, yeah. The 2 is a what? Oh, I'm looking at the wrong thing. I'm sorry. I'm looking at this one. Good Lord. No wonder you're like, what? Sorry. I was looking at the wrong function. Back up. I'm back in the middle one now. I was just looking at the wrong one. I'm at 0, 0. The only thing that happens is it shifts down. It helps if I'm looking at the correct function. So since the only thing that happens is that it shifts down, then when I use -1, -1, that's where this point comes from. So when I use 1, 1, and I shift it down, it's right here. These 3 points are important. And if you don't know what the parent function looks like, and you don't understand that those are the anchor points that are right around that point of inflection, then you don't know how to draw your curve in there. So then now to draw this, it just looks like this. So it's just that part of the cubic. Okay. I'm waiting. No, you don't, because it's stopping there. The arrows imply that it's going on forever, but this is the middle part that's defined by that interval. Okay, that's a good question. All right, and Kendall, I heard a wait. Do you have a question, or are you just fixing something? You're good? Okay, I just want to make sure we weren't confused. All right, so then for the last one, I'm going to substitute in 2. 2 times 2 is 4. Square root of 4 is 2. So I have -2 plus 1 is -1. So I go to 2, -1, and I have an open circle. So for my square root function, my anchor points are 0, 0, 1, 1, and 4, 2. So if I start at 0, 0, and I reflect, nothing happens. I compress, nothing happens. I go up 1. That's not even in my domain. And 1, 1's not going to be either. So let's try 4, 2. I'm going to start at 4, 2. That negative reflects it in the x-axis. What does the 2 do? Horizontal compression by 2, and then up 1. That is that point, right? So I need another point. If I'm doing the square root of x, my anchor points, there's a reason I'm not using x equals 2, right? There's a reason I go to 4. So what would be the next one that would help? Close, I want the square root. 9. So I'm going to go to 9, what? 3. Okay, so 9 goes off the graph, but it's okay. I reflect it in the x-axis. Then I horizontally compress by 1/2, so that 9 becomes 4.5. 1, 2, 3, 4.5. And then I go up 1. Oops, and that's solid. And so since I know what the square root function looks like, and I understand how it reflected, that's really all I need to get the curve that goes like so. Okay. So domain, is it all real numbers? Yes. So it's -infinity to infinity. What about the range? Do I start at -infinity? Yeah. Because this is going to keep going, right? Slowly, but it keeps going. So -infinity to what? 7. And do I include the 7? Yes. Do I have any discontinuities? Yes. I have jump at x equals -1. And at what? X equals 2. All right, what questions do you have? What do you mean by it doesn't count for anything? I'm sorry, what was the second part of that? Oh, well, yes and no. It counts because it's part of the jump for this one, and it's part of the jump for this one. Okay, does that make sense? Anything else? We're good? Awesome. All right, go ahead and get that taped in.